All right, so everybody, welcome to our class today, our class on Introduction to Networks. I'm hoping, there we go. So I've given you 4 binary numbers, and I want you to convert them very quickly to decimal numbers. So take a few seconds here and do that. We'll take a few minutes. Remembering again, in the octet, we have the bit positions of 2 to the 0, to the 1, to the 2, to the 3, to the 4, to the 5, to the 6, and 2 to the 7. And the values of 1, 2, 4, 8, 16, 32, 64, and 128, which make up our octet. Take just a couple minutes here and do these. Turn my phones off so it ding. Okay, so what is the method used to convert from binary to decimal? Caleb.
Addition.
The addition method. So what we're going to do is we're going to look and we're going to say, is the 128-bit position turned on? The answer is no. So we do not add that in. Is the 64 position turned on? No. Have I dropped the pin? The answer is yes. Sorry about that, y'all.
1, 0, 1.
Yeah. Now 32 is turned on, as is 16, and then 8, 4, 2, and then 1 is turned on. So at this point, the correct answer is 49.
49, yep.
Okay, so very easy to do, and you'll notice that it's just the addition method. I can also know immediately that this is going to be an odd number, because that bit position is turned on. These are all going to be even numbers. Okay, so let's erase here. I'll erase it a little bigger.
You can use the fist. Use the.
I'll do it like that.
Yeah.
All right, much better. All right, so let's look at our next one. I can look at this one pretty quickly and tell you that this is going to be just 128 plus what? 16? What's our final?
142?
140.
144.
144. 11 6 is 14, carry 1 is 144.
That's right. That's right.
So that one's good. Now, this one is really easy because this one's the one one of the ones I told you to remember. 128 plus 64 plus 32 equals 224. That's one of our given ones. Okay. I give it that.
No. I think you just drag it down.
Yeah, just give it up. That's fine.
Or, yeah.
There it is, the note. Okay, now, this last one here is very simple too, because it's just 2 and 8. So this is 10. So remember, if we're converting from binary to decimal, you use the addition method. All right. Now let's do a couple the other way. I mean, it is neat to be able to use your hand to do that. Oh, it's probably very bad during COVID time to use a hand to erase stuff, but still.
I just spray that with bleach.
That's what I say. So let's do 204. Let's do 67, 35, and 22. So convert, these are all base 10, so these are decimal. So let's convert them to binary. So take a couple minutes. The method will be the subtraction method. Remember that. We use the subtraction method now to convert. So we'll have the subtraction method. So let's look at it. 204, Can you subtract 128 from it?
Yes.
Yep. So we're gonna go over here and we put a 1 here. What's our remainder?
76.
76. Can you subtract 64 from 76?
Yep.
Yep. Leaves you 12, right? Can you subtract 32 from 12? Nope. You can't subtract 16 from there either. I also know that 8 and 4 is 12, so I can just do that right there because I can subtract 8, which leaves 4, and subtract 4, which gives me 0. And the correct binary number for 204 is 11001100. Okay. 67 is a very easy one when you do some thinking about it, because let's think about it. 67 is turn on 64 and then add 3 to it. Okay. Now, if we need to do this again, we would just subtract. So 64 from 67 is 3, and then leave on the 2, 1. 35 likewise. 35 is also a very simple one. So we can't subtract 128, we can't subtract 64, we can't subtract 32, which leaves 3, which will be these last 2 turned on. There we go. And then 22, can't subtract 128, 64, or 32. You can subtract 16, which leaves you with 6, right? Can't subtract 8, which can 4 and 2, and there you go. So 00010110 is 22 in binary. So just a quick review of those. This is the subtraction method to go from decimal to binary. Now, we talked a little bit about IP addresses and classes. We talked about the fact that 192.168.12.0/24. This would be what class of address? Anybody?
C.
Everybody agree this is a class C?
Yeah.
Okay, for a couple reasons. One, the number here is 192, and the correct, anything that's 192 to 223 is in the class C range. It also begins with 110 in binary, if you convert that to binary, which also means it's class C. So this is a set, this is your network right here. Okay, so 24 bits. Again, that's why we have these 24 ones in our subnet mask. 24 bits are the network, and these 8 bits make up the host. So this is a single network of 254 usable hosts. Now, you may be confused by that because our range is 0 to 255, which is actually 256 positions. But remember, the host address cannot be all zeros, and the host address cannot be all ones. So therefore, out of this entire network, there are only 254 usable addresses. This is all fine and dandy right up until I do this, and I look at you and say, but guess what? I'm going to give you this network. Okay, so these are routers and switches. So you've got on this particular network, you've got hosts down here hanging off, and you got, we'll just leave it with that, okay? So we got 3 routers and 2 switches and hosts, 2 little happy hosts down here hanging out, okay? He may not be that happy, okay? Now, the thing that's wild about this is I've given you a single network, but I have asked you to actually try to apply it to an internetwork that needs a network here, a shared network here, a shared network here, and then a network here. So in other words, you actually need 4 networks, but I only gave you 1. Now, what you could do is you could say, well, Kelly, can I have 4 more networks? And if I said yes, we'd come in here and we'd say, okay, well, this can be 192.168.12.0/24. This network can go in this blue section. This network, 192.168.13.0/24, could go right here. Now that's gonna be a massive waste of space because we only have, this is a point-to-point link, so you're only gonna have 2 IP addresses, that one and that one. And then over here would be 192.168.14.0/24 and 192.168.15.0/24. Okay, so you could ask me and I could say, okay, yeah, you can have, 2, 3 more networks. But more than likely, I'm gonna say, nope, sorry, can't do that. What you're gonna have to do is you're gonna have to subnet this network in order to use it on this inner network. Now, subnetting. The definition of subnetting, hopefully you watched my video on the 7 holy steps of subnetting. I'm going to actually go over just today, just classical subnetting. I'm not going to go over classless today. But subnetting is borrowing host bits to increase the number of network bits. Whoa, my hand got all kind of out of control there.
Hey, you ready to walk in yet?
Mhm.
Yeah.
The network bits.
All right. Thank you. I'm just make sure you see my face.
Okay, hold on. I will in a second.
Okay, no problem. So, and yeah, you can come right back up as soon as you get done invest bias. You're welcome to stay unmuted if you want once the noise stops there. But subnetting is borrowing host bits to increase the number of network bits. So in our network here, we've got, switch over. We've got 1 network, okay? But we need 4 networks. So we're gonna borrow some of these bits here to increase our number of networks. So let's go over here and let's say, step 1 in the 7 holy steps of subnetting is determine the number of networks you need. Well, there could be a couple ways. I could tell you, you need 4, you need 8, you need 10. Or when you look at a network, every port on a router is going to be in a different network. So that's a network right here off of this. Now this, because it's a shared point-to-point link, this will be 1 network. This will be 1 network. And then down here will be a network. So these are shared networks. So how many networks do we need right here? 4. We need 4. So we need 4 subnets. Now step 2, I always have my students write out your host bits. So let's go back over here and look. We've got this network. So we've got 8 host bits. So we're going to come over here and we're going to write out 8 host bits. 1, 2, 3, 4, 5, 6, 7, 8. Now, later on down the road, when you get better at this, you don't necessarily have to write these out. I do this though because I want you to realize the definition is for subnetting, you are borrowing host bits to increase the number of network bits, which means the number of hosts on each network is going to decrease. Okay, so step 3, we got a formula here. Change the color back. Step 3, we've got a formula that will tell you how many bits you have to borrow to get the needed number of subnets, and that is 2 to the n equals the number of subnets. And n, in this case, equals the number of bits borrowed. Okay, so what power of 2 do I have to raise 2 to in order to get 4 subnets? 2. 2 to the 0 is 1, 2 to the 2 is 2. So actually it'd be 2 to the 2 to 0, 2 to 0 is 1, 2 to 1 is 2, 2 to the 3 is 4. So n equals 4, correct? Excuse me, not 4, 3. Because we need to borrow 3 bits. Because 2 to the 3rd power, 2 to the 2 is 4, 4 to the 2 is 8. Actually just be 2, and I'm brain farting.
Yeah, because 2 to 0 is 1, 2 to 1 is 2, 2 to 2.
It is 3, I'm sorry. Man, I am brain farting bad today, y'all.
2 to 0 is 1, 2 to 1 is 2.
Two to
2 is 4.
correct.
So it'd be 2.
2. You're right. Sorry. Golly, y'all. Long day.
Too
My
late.
grandmother passed away a little earlier today, so it's been a rough day. Step 4, we're going to turn on the number of bits that we're borrowing from step 3. So let's go in here, and by turning them on, we set them to 1, starting from our high order bit. So 1, 2, 3, 4, 5, 6, 7, 8. And we find the value there. So what is 1, 1 and all zeros? 192. Okay. Step 5. Do it again. I always forget to change back my colors. Step 5, folks, is determine the new mask, because now that I've borrowed 2 bits, my mask is no longer /24. It's now /26. So we take our old mask, which was 255, 255, 255.0, and we add to it the 192. So that's the new mask when I borrow 2 bits. Step 6, we need to find our variable. And this is the variable that is going to be used to find out the size or the length of our subnets. And in this case, each octet will have a variable, but in our case here, we only have 1 octet we're working in because we're only working with 8 bits. The variable is found by going up to step 4, finding the highest lower bit turned on. Okay, so left to right. What's the value right there?
64.
64. So our variable is 64. Now, step 7 is actually writing out our subnet. So let's go over here and write out. You begin with the major network number, which is 192.168.12.0. Okay. Now, since we're only dealing with the 4th octet here, I'm not going to write out 192.168.12.0 every time. But then we're going to rotate, or we're going to use a variable of 64 for each one of our subnets. Sorry, y'all, my handwriting's getting worse. So now, instead of 1 network, okay, of 254 hosts, we have subnetted this to be 4 subnets. And you can see there's 1, 2, 3, 4, 5, 6 host bits left. So if you want to know how many hosts are ever on a subnet, you can use a formula called 2 to the h minus 2 equals the number of hosts on a subnet. And that's where h equals the number of host bits. So what is 2 to the 6 minus 2?
2 is 30.
That is correct. So 2 to the 6 minus 2 equals 30 hosts. Now somebody should be asking, well, where are those 2 hosts going? Exactly. You've got your subnet ID and you've got your broadcast ID. If you look at this in binary, there's all zeros in the host bits. Here, there's all ones. Likewise, there's all zeros here. There's all ones here. So that's where those 2 hosts are going, if you ever wonder why we're losing 2 hosts.
Now, shouldn't that be 62? Shouldn't that be
What?
62 hosts instead of 30?
62, yep, sorry. Yep, did that wrong. I trusted your math, man. 2 to the 6 is 64.
Yeah, that's right.
2 to 6, 64 minus 2. I blame that on Caleb.
Okay.
That's Caleb's math. Now, if we need to prove that this is actually true, what's this? Hey, y'all, watch this. Let's take our new mask. And by the way, we know if we put the mask in all ones of 192.168.12, we put 255, 255, 255, these 3 numbers are going to fall through, right?
Mm-hmm.
Okay. So let's take 64. 128, 64, 32, 16, 8, 4, 2, 1. Let's take our new mask, which in this case is this, and we'll do 1, 1, 2, 3, 4, 5, 6, 7. If you add this together, 0, 1, 0, 0, 0, 0, 0, 0. Look what happened. All of the host bits are zeros. So 64 is not a usable IP address on a host. 127, by the way, is that, and you still end up with all zeros. Okay. So you got actually end up with all ones in the host bits right here. So you got all zeros or all ones. Now look at this. Here's something that's cool. I'm gonna show you this. Let's take 65. 65. Let's take 65 and do 128, 64, 32, 16, 8, 4, 2, 1. Okay. Let's look at our network bits, or let's look at our host bits. Here's our host bits, right? Are they all ones? Are they all zeros? Nope. So as long as these are not all ones or all zeros, then you can use it. That's why we lose the first and the last of every subnet. Now, the bad news is that means you're losing, as you subnet, you lose more addresses with the more subnets you create. But the good news is now we could come over here to this network and we could use on this network the 192.168.12.0/26 network, which is the network 0 to 63. We could use 64 to 127 here. We could use 128 to 191 here. And down here, we could use 192 to 255. And these are all in the 4th octet, by the way, because we would keep 192.168.12. So we took this Class C, which was one network of 254 hosts, and we broke it into 4 subnets of 62 hosts.
And when you're putting it in there, you would put them all in as -26, right?
/26, correct. That's why this is called classful addressing.
Yeah. How would you differentiate the 4 different ones if they're all .0/26?
They're not going to be .0/26.
Okay.
Because here's what's going to happen. This host right here, okay, good question. Let me do this. Let me erase this. And now let me and something for you. Let's do some anding. Okay, because here's what's going to happen. If we take, for instance, let's imagine that we put .65 on this host, this router's interface here, and .66 here. Okay. So we take 192.168.12.65, and I'm going to actually convert 65 to binary, 128, 64, 32, 16, 8, 4, 2, 1. Okay. Now, if we add this to 255.255.192, okay, and let me take 192 and write it binary. 1, 2, 3, 4, 5, 6, 7, 8. Look what network it's on. This is the 64 network. This right here is the 0/26 network. This is the 128/26. This is the 192/26. So each one of them's on a separate network because of this /26 mask. Now where you'll get in trouble is if you accidentally do the following. If you put /24 here and then try to use /26 here, it's going to tell you it overlaps because these are part of that entire network. So if you ever get a thing that says IP addresses are overlapping when you're trying to put them on interfaces on a router, more than likely you've got the wrong mask. Okay, let's try something different. Let's do this. Let's give you the 192.168.12.0/24. And I want you to subnet this for 2 subnets using my method, using the 7 holy steps of subnet. So 2 subnets. So you got step 1 taken care of. So go ahead and do that right now using, golly, I cannot write. Step 1, 2 subnets. So take a couple minutes and run through all 7 steps. I know it's a little bit cumbersome, but do it just for now.
Can you put the steps back up?
Yep. And put steps over here. Hold on. There you go. Okay, so let's see here. So step 1, 2 subnets. Step 2, how many host bits do you have?
8.
It's 8 host bits. Okay, so that doesn't change because we got the same base class C we're starting with. Sorry, folks. I don't know why that phone's ringing. Step 3, how many bits will we need to borrow in order to get the number of subnets? 1. Okay, so we're actually going to have n equals 1. Step 4, turn on the number of bits that you're going to borrow. All right. Step 5, find your new subnet mask. This is a weird looking mask here because it's 255.255.255.128 or /25. There's another way of writing it. Step 6, we find our variable. So we're going to go up here and we're going to look and see, okay, our variable right here is 128. And then step 7, we're going to find our ranges, which I'm just going to be very lazy and write down just 0 to 127 and 128 to 255. So we split this from one network of 254 hosts to 2 subnets of 126 hosts. Because there's 7 host bits left, and 2 to the 7th, 128. All right? So very simple. In fact, when you look at a class C or a /24, there's the only possibility that you can actually do is you can only borrow between 1 and 6 bits. You can never borrow more than that. And that's because of this little mathematical formula right here. 2 to the h minus 2 equals your number of hosts. So think about it. If you don't leave at least 2 host bits, 2 to the second power minus 2 equals 2, right? 2 to 1, 2 to 0 is 1, 2 to 1 is 2, 2 to 3, yeah. So it'd be 1. Anyway, you gotta leave 2 hosts. If you don't, what happens is this: 1, 2, 3, 4, 5, 6, 7, 8. Okay, you leave 2 host bits. 2 to the second power is 2. 2 to the second power is 4. Minus 2 is 2. So this allows for 2 hosts per network. And by the way, you'll see this all the time as /30. And that is typically what you see on any of your point-to-point links. So it's point-to-point because there's only 2 usable hosts here. So for instance, let's take this one and actually do this all the way down to, we're going to say we want to do six. Let's just go ahead and borrow, we're going to borrow 6 bits. So let's go in here and borrow 6. Okay, so we're going to take this, turn this green. 1, 2, 3, 4, 5, 6, 7, 8. What's your new mask going to be? It's going to be 252/30. Your variable now is going to be 4. And so your ranges, and you get a whole lot of subnets with this, by the way, but your range now becomes the following: 0 to 3, 4 to 7, 8 to 11, all the way up to 252 to 255. You'll notice this is not usable because it is the subnet ID. This is not usable because it's the broadcast ID. So the only usable addresses right here are .1 and .2. But that's perfect for a point-to-point link. Okay. This is classical subnetting because if we did this, we would assume that every single network that we have uses the same mask. When we say classical, that's what we mean. Classical subnetting is that all subnets use the same mask, have the same mask. That used to be all we could do. So we had some issues with our subnetting because of this. It's very important though to learn to do this type of subnetting before you do classical. So let's do this. Let's take the same network again, 192.12.0/24. And let's go for 60 subnets. Okay, so step 1, you need 60 subnets. So let's subnet the same for 60 subnets. By the way, I did a little thing, I told y'all this the other day. I do this on all of my tests. Before I ever click start, just to keep me from doing something stupid, which I obviously always do. So 2 to 0 is 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. So that'll help you a little bit there. So let's work on this one. Subnet it for 60 subnets. Okay. So step 2 hasn't changed any. We still only have, and again, this is a step you can eventually just quit doing altogether, but I like it because it makes you focus on the fact you are borrowing those host bits. All right. Step 3. What power of 2 do I have to raise 2 in order to get the needed number of subnets?
6.
It's going to be 6. So n is going to equal 6 to give us 64 possible networks. Now, it's a little more than what we need, but that's as close as you can go. You know, and on the exam, one of the things I would do typically, especially whether you're using classful or classless subnetting, is get as close as you can to what they ask for. Okay. Step 4, let's borrow those. Okay. So in this case, we're going to borrow those. And guess what we're going to end up with? 6, 7, 8. Step 5, we're going to end up with the exact same thing we had before. And the reason I did this is to show you something very important. Yes, I can get, what is this, 252? I can get 60 subnets. But the problem is those subnets only have 2 hosts apiece on them. So we can keep going here. We do step 6, our variable equals 4, and we're going to end up with the exact same thing we had before. Okay, variable is 4, so 0 to 3, 4 to 7, so on and so forth. So the negative impact of borrowing bits to get more networks is we lose host bits. So while this is possible to get 60 subnets out of what is a /24 notation, it's not very usable unless you've only got a bunch of point-to-point networks. All right. Now I want to show you another variation of this classful subnetting, something that people don't think about much, but is very easy to do. Let's imagine that I ask you, instead of the number of subnets, I want each one of my networks to have 10 hosts. How would I change this? Well, remember our formula. 2 to the h equals 2 to the h minus 2 equals the number of hosts, right? I've got to have at least 10 hosts. If I raise 2 to the 4th power minus 2, that's going to give me 14 hosts per subnet, right? So this is telling me that I've got to have at least 4 host bits. I've got this network right here. It's got 8 host bits in it. So I've got to have 4 of those as host bits. The other ones can be my network bits. And then now we just do it like we normally would. We go and say, okay, our variable right here. Well, first off, our new subnet mask is 255.255.240. Calls 128 if it's all zeros, 192, 224, 240. Our variable right here is 124816, right? So our variable is 16. So now I can come over here and start doing my 0 to 15, 16 to 31, all the way down to 240 to 255. So I broke it into, by the way, 2 to the, got 4 bits here we borrowed. So we got actually 16 subnets of 16 hosts. 14 hosts, excuse me, 16 subnets of 14 hosts. So if you're ever asked to subnet based on the number of hosts, just remember you've got to leave that number of host bits. Those host bits have to be left in order for you to be able to do that. Now this is classful addressing. This is not how the curriculum teaches it. The curriculum teaches it by saying, okay, you're going to borrow first this amount, then you borrow 1 bit, and that gives you a variable of 128. And so your variable is 128, it's 0 to 127, 128 to 255. Okay. If you need 4 subnets, you're going to borrow 2 bits. And then it just goes on and shows you doing it by doing the slash, so like you do a /25, /26, /27. And that works fine if it's all a class C, because you got your variable of 128, your variable of 64, your variable of 32, on and so on and so forth. Okay. But I think it's important you need to know how to do this. And now, as our last little item I'm going to show you today, I'm going to come in here and I'm going to take 131.107.0.0/16. And I'm going to say I need 2 subnets. So step 1, we need 2 subnets. I'll show you how this will work even if you are crossing what I call the bit boundary. Step 2, write out your host bits. Now this part gets a little boring because you got to write all these out. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Dot. 1, 2, 3, 4, 5, 6, 7, 8. So now we've got 16 host bits instead of the 8 we had before, because this is /16, which tells me we have 16 host bits and 16 network bits. We have step 3, which is 2 to the n equals the number of subnets. So in this case, n equals 1. Step 4, we turn that on. And again, this gets a little boring here, but just so you can see it. 4, 5, 6, 7, 8. Dot. 2, 3, 4, 5, 6, 7, 8. Our new mask is the old mask. So the /16 mask, which was 255.255. Add to it the value in the 4th step, which is 128.0, because we converted that. That's 128, that's 0. Step 6 changes slightly, because watch this. We have a variable for our 3rd octet. Okay, so we're going to look here and say there's the variable for the 3rd octet, which is 128. But because we're crossing the bit boundaries, we got more than 8 bits. We're also going to have a variable in the 4th octet. But in this case, because nothing was borrowed from the 4th octet, there's no variable there.
0 to 255.
0 to 2, exactly. 0 to 255 because nothing was borrowed. So we actually now have 131.107.0.0 to 131.107.127.255. Because we're rolling the 3rd octet by our variable 128. And now that that is rolled, we now go 131.107.128.0 to 131.107.255.255. So we broke this class B address for a /16 notation. By the way, this could just as easily have been 10.0.0.0/16. Almost this is a /16. That just means it's already been subnetted once and you're subnetting it again. Okay? But you'll notice the rules work just fine here. If I said we needed enough subnets to get us into this octet, all we would do is we would change the variable in the 4th octet. So we'll do 1 or 2 of those next week in our next meeting. Okay? So take this as the basis of what we're doing. Spend some time looking at the rest of chapter 10, 11, and the networking that's in there. And we'll move forward and continue to talk about IP addressing, because out of all the things that are in CCNA 1, IP addressing is probably, and subnetting is the #1 thing that you need to know, followed by basic configurations of devices, followed by probably networking theory. But this is something you will use your entire career as someone in networking. Any questions? Any questions before I leave the whiteboard here? Nobody? Anybody still here? Looks like there's 5 of you here.
Still here.
Okay.
My question,
We're here.
but like, how does that turn into classless subnetting? Because I mean,
We'll do that next week.
yeah,
We'll talk about classless next week. By the way, classless subnetting, classless, which is also called VLSM, okay, or variable length subnet masking, is pulling out pieces to meet your needs.
okay.
And I'll go over that next week. And we'll go over that next week. Because really, we're still wasting a lot of addresses. Here's the problem. You know, if we use our old, this method of classical addressing, you know, this work, we got our 4 networks, but we're wasting a bunch of, ton of addresses up here. Because we only need 2.
Yeah.
Wouldn't it be nice to be able to put a /30 here and a /26 here? That's what we're going to do with VLSM.
Okay.
We're going to be able to take this network, and instead of doing the classical subnetting where the mask has to be the same, we're going to pull out a piece to go here that's only a /30. We'll pull out a piece here to go to /30. Pull out a /26 here, or maybe a /28. We'll be able to put pieces onto the puzzle to match the number of hosts we need, instead of having to just have the same number of hosts in every subnet. But it's very hard to understand classless unless you understand classful, because you need to understand that to begin with, this is how we had to work. And the reason we had to work like this is because our routing protocols could not send subnet mask information within the route table updates. Now modern protocols can, so we do everything classless. Okay, so that question was, how does VLSM relate to this? This is the grandfather to VLSM. This is the basis upon which VLSM works. So just real quick, I'll show you I'll do a quick example, but let's just imagine that with this 192.168.12.0/24, one of the first things we could do is we could just borrow 1 bit, which would be /25, which would split this into 0 to 127, and 128 to 255, okay? Then we can say, all right, well, this is still too big for what we need, so we go to /26. Now our variable is 64, so 0 to 63, and 64 to 127. By the way, sometimes you'll hear VLSM described as subnetting a subnet. So we've taken this subnet here, and we subnetted it again. So let's borrow another bit, so /27. So now our variable is 32, so 0 to 31, 32 to 63. Go to /28, which is 16 now, so 0 to 15, and 16 to 31. All right, I'm gonna jump down here, /29. It's gonna be 0 to 7, and 8 to 15. So I'm just breaking this one down into this. And then /30, which is as far as we can go, is 0 to 3 and 4 to 7. So I could pull out the 192.168.12.0/30 network, and I could put that on one of my point to points. I could pull out 192.168.12.4/30, put that on the other one. Okay, so now this has been used and this has been used, because that's included in this and this, this, and this. None of those can be used now. But I could go and grab this network and use it. Not the values, 0 to 7 are not anywhere in 64 to 127. So I could take 192.168.12.64/26, and I could use that.
So you could use -29, 8 to 15?
Yes,
Okay.
because it's not, as long as it's not overlapping. Yep, I sure could. This will be fine to use as long as you use it as a /29. Correct. Yep. The only place you get in trouble is you try to use something that's in here to be an overlapping. But But the beauty of classless or VLSM is you can pick and choose the size of subnets that you need to match the number of hosts. Excellent. Very good question. Okay, folks, with that, I'm done for the day. So I'm going to stop my share here. I'll also end the recording.